Okay, the next one is called Sensor Open Systems Architecture. Like I mentioned, this was an effort that Dr. Ilya Lipkin, who works at Air Force Lifecycle Management Center at Wright-Patterson Air Force Base, and myself started when I was at Air Force Research Labs. This is an effort that is focused solely on how we can take all the different types of RF sensors that are being fielded today and how we can get them to interface with each other seamlessly, whether it's on a pod, it's on a different type of fixed wing or rotary wing platform. This is the chart that I mentioned before. This is the thing that you'll see, I see a lot of when we talk about these trends, is that today and going forward, the systems that the government wants to purchase or use in the field are growing more and more complicated. What you need to do to get them to field is becoming more and more costly. And unless we do something about it, which is the reason why the government is so focused on using open system architectures in general, it's going to break. There's not going to be any way that we can field any type of complicated system given the cost that's going to incur to the government. This ties into that thing I mentioned in host about faster with the functional decomposition. This is what SOSA is based upon because SOSA actually is incubating inside the same organization that FACE is in right now. And what SOSA wants to do is break down what you see in the top left into functional building blocks that you can reorganize, reconfigure into a system where you can say, okay, for this application, I will use it this way. For this application, I will use it this way. And that's one of the tenets for SOSA based upon sensor systems for C4ISR. So the things that we are concerned about, which everybody I think in this room could understand, there are business concerns that we have to think about in terms of, we say we want to do this, how's it going to look to the community who are the ones that are actually building these components for us? How's it going to affect them? What types of weapons and sensors are we looking at using? So the sensor modalities that we're looking at today would be EOIR, EW, comms, RF, and SIGINT. So those are the ones that we're looking at right now. Now the platforms that we're looking at could be on a larger scale UAV, could be on a C-130, could be on MH-60, it could be on a Reaper. That's kind of where we are right now. We're thinking about the standards between the subsystems. Like I mentioned before, UAVs, the software architecture and the ISR types of systems and the sensors, communications links and CNC, and the data dissemination. These are all the things that we're concerned about and how we can get them to work together as part of this sensor open system architecture. So there were choices that could be made, and you'll see this later on about whether we do it like we've done before with OpenVPX or Space VPX in terms of a consortium. The thing that we decided on was that being in a consortium with both government and industry was the best choice, given that we could work together from the get-go if there was interest from both parties or all the parties to say, okay, how can we make this more affordable? How can we get more technologies to the field faster? And how we can actually develop technologies that would last longer over a period of time that could be scalable or flexible. So all the things in the air, I won't go through each one. They're all the things that I think that you guys can see in terms of what you do in VITA and the other organizations that make the most sense, as opposed to us funding somebody to do it for us. And we say, okay, well, it's an open standard, which is not really. We paid you to build something for us. So within SOSA, in terms of the scope and the working groups right now, we have 5. The hardware working group is the one that I'm chairing currently, along with Jason Derner from CERDEC. So we have Air Force, Army, and Navy inside the hard working group developing what could be called next-gen boxes that are leveraging OpenVPX. We have a software working group that has a chair from Lockheed Martin that's looking to see, okay, what can we do for software portability? How can we look at third-party APIs to develop these systems so that you can have softwares from one application to the next? There's an enterprise working group chaired by a gentleman from Raytheon outside of Boston who's looking to develop the overarching architecture for SOSA. How do we build it such that we know how to define each of the terms, each of the functions, and how we know that it'll go from one app to the next app. There's a business working group that's looking to find out, okay, what do we need to do to market this effectively to the community at large? That's not just to you guys, but to other customers. And there's electromechanical working group that's chaired by a gentleman from L3 Sonoma that's looking to derive existing specs for how you connect the payloads themselves to the platforms. The spec that they're leveraging is called Spies, which was actually funded by the Navy, I think probably 5 or 6 years ago. In terms of comparison table, these are just 3 of the big ones. I mean, if people are aware of FACE, they kind of know what we're talking about. If people know what Open Mission Systems is, that's an effort that was started by the Air Force Rapid Capabilities Office. And it's basically not in competition with FACE, but it sits one layer down. So it's a messaging format or a messaging standard, presumably for ISR and RF systems. And then for SOSA, we're trying to see how we fit in because we're looking at large customers. And for us, the large customers at this point are what's going on either between the Navy, and the Army, and the Air Force. And so the Navy's pushing FACE. The Air Force right now is pushing OMS. And we want to see where SOSA fits in with all that, where we have the sort of common themes. In terms of visions and goals, I'll go through this real quick. It's all the same standard stuff. I don't mean to misuse the word. In terms of one, we want to foster innovation. We want to have engagement with industry and increase competition. We want to have rapid fielding. We want to minimize logistical requirements so we can get these things out to the end user. This is just a snapshot of who's involved. Like I mentioned, the Air Force, Army, and Navy are all involved in this to date. And at point of fact, there's actually a SOSA face-to-face meeting going on right now at the same time as this meeting's happening. Not here, it's in Florida. And in terms of industry participation, those are all the companies that are involved right now with SOSA. Old draft overview. The bottom right gives you an idea of an SV1, a system view of what we're talking about. So we're really focused on the sensor part of the system. And that includes the sensor itself and all the peripheral compute processing, electronics, everything else. Anything outside of that that's not part of our scope. Okay, hardware convergent slot profiles. So, Greg, has it been a year since we started? I don't remember. About a year ago, the Army and the Navy and the Air Force got together and decided that we're all doing the same thing. We're working with the same standards. We want to leverage the same standards. So we decided on how we could go forward and leverage that type of effort. So we decided to figure out, for Army, it's essentially the same idea. They have sensors on a platform. It's a ground vehicle as opposed to an air vehicle. For SOSA, it's all about sensors on an air vehicle. For the Air Force, it's the same idea. The Navy would include surface vessels as well as air vessels. So we've agreed on, to date, a series of slot profiles, base slot profiles, and module profiles that we all will leverage that are coming out of OpenVPX. The thing you see on the top as an example is the 2F2U that we all are going to leverage. Army, Navy, and Air Force, once you see the specs, you're all going to see these slot profiles in the specs. We're all going to want to be using these slot profiles for a variety number of systems. The host switch on the bottom left was agreed upon between the Army and the Navy. The Air Force, through SOSA, is going to adopt that. The CMOS switch, which was coming from what Greg is doing with SERDEC, is that right, Greg? And is going to be adopted by the Navy and the Air Force. And then the SOSA RF payload, which is what my colleague Ilya wants to call, is what he's going to direct adopt from what SERDEC's doing. So the bottom line in this is that we're all going to be leveraging a common set of slot profiles and module profiles. There won't be any divergence in as much as we can do that between those three services. From the electrical mechanical side, like I mentioned, we're going to be leveraging Spies, which is an existing standard that was developed by the Navy and the vendor community. This just gives you a sort of a functional breakdown of what they're looking at in terms of the types of interfaces they want to standardize on. There's actually, I think they're going through this week in the SOSA face-to-face, they have a spreadsheet where they've defined the signal, it's a pin map and the signal definitions for the Spies connectors, which are essentially 38999 connectors in varying size, whether they have straight up electrical connections, RF, or optical. So there's been some convergence on that already. This is an example of a pod that we're going to use. There's going to be a series of demonstrations funded by the Air Force to show the benefits of using SOSA, the SOSA interfaces. Right now, we're going to be using this pod with a variety of modalities. We have hardware coming in from SERDEC, Northrop Grumman, and Lockheed Martin, so we have boxes. We may have boxes coming in from the Navy as well to show the interoperability between those boxes and how we can demonstrate in an example or a mission profile how we can either swap out boxes, swap out cards, swap out payloads, and shorten the time where we can go from one mission profile to the next.